Gives me great pleasure to welcome you to the launch of Global Enterprise for Micromechanics and Molecular Medicine, now commonly referred to as GEM4.
GEM4 is a fundamentally collaborative effort, and the program for this launch reflects the same approach.
When you look up the literature, you see about 56 papers in Chinese, which have been translated to English, all working together from these various universities and cities.
Could we actually create brand new tissues in the body? And this is a really, I think, very powerful example of interdisciplinary research.
GEM4 was created in 2005 as a way to bring together faculty, students, and researchers from many different institutions around the world who have a common interest in addressing major challenges related to human health.
The super came an idea of a virtual institute that you draw from different disciplines around the world to look at some of the most exciting problems that lie at the intersections of science, engineering, medicine, and public health.
We're creating a new generation of engineers/scientists at the engineering-biology interface.
Part of moving biology forward is to help it become a more quantitative, system-based biology as opposed to a focus at simply the molecular and cellular level.
The collaborative effort between engineering and biology would have huge impact on things like healthcare, environment, security.
You can think about cell biology, nanotechnology, imaging.
Biologists realize that they too now have to know something about mechanics, just as a person coming from mechanics already realizes that they need to know something about biology if they're going to try to contribute to this field.
You really need to have a team. It's not just to do experiments, you need to do modeling, you need to do computation. So for any single lab to do all that is impossible. Therefore, collaboration is very critical.
The problems are medical in nature, but the science is biological, and the solutions, many of them are engineering in nature.
Part of the mission of GEM4 is to create new educational opportunities and educational content by bringing together experts from very different fields and very different geographical locations to come and teach in a program for which there are no existing textbooks. And the people who participate in these summer schools are the world's leading experts working at the very cutting edge of technology.
It was a 2-week-long course. It's very intense. All the students that are involved come together on a single campus, and it rotates among the campuses.
In addition to the lectures, the students have had the opportunity to get hands-on experience in labs in different institutions around the world.
There are places all over the world that are asking us if they can have a GEM4 summer school because they realize that it's a way to really bring in the biomechanics community to their country.
We have major revolutions in many different fields that have previously not overlapped. One of the initial projects was in the area of malaria. A number of institutions got together and tried to formulate collaborative platforms through which different aspects of malaria could be addressed.
In cardiovascular research, a very critical issue is the development of plaques on the vessel wall. So our effort within GEM4 is to understand how the mechanical signal due to the change of blood flow patterns induces plaque formation. And of course that leads to a better understanding of the cardiovascular diseases. Over the next 5 years, we'll go beyond just biomechanics. We'll include synthetic biology issues related to cellular machines.
Promote interdisciplinary research to break down the walls between the different academic units, because that's where the action is.
Seek to develop new ways in which we can understand human diseases and we can try to develop, if not a cure, at least methodologies to address human diseases on a global scale.